Okay, welcome again to Vectors, where we are going to focus our discussion on how to resolve the vectors and also how to read the angles. Okay, so the first class of questions that we can be asked are one, they can give you a question which is saying, given angle which is read like maybe east of south. And how do you write east of south in this case? Specifically, we are trying to look at such type of questions whereby if they say east of south, and how do you write this same east of south? Suppose this was a compass to say this can be my north, this one is going to be my east, and this one is going to be my west. Finally, this is going to be what? My south. So based on this same compass, what are you supposed to do if they say east of south? For you to read the angles, you can be given an angle, maybe let's say they say 20 degrees east of south, meaning that what you're going to do, you draw this angle on the compass depending on what you have been given. But whenever it comes to reading the same angle, you won't read according to the way it is. Remember, always we read angles from positive x axis, mostly where the resolving of vectors into components is concerned. So long you have been asked a question whereby you want to resolve a given vector into its components, what are you supposed to do? Based on this, if you have been given your question in this type, what mostly you're likely to do is you're going to write this angle by following the last thing or the last pole. If they say, sorry, this has to be east of south, sorry. If they say east of, I put of here, east of south, meaning that what you're going to do for you to write this same 20 degrees, you need to start from where? You're going to start from south moving towards the east. So definitely you draw a line which is lying in this quadrant. That's where the vector maybe A is located. So since they're saying east of south, look at what you've been given at the end. That's where you start from reading that's where you start from drawing your angle. Meaning that I'm going to move from this given point, moving counterclockwise or anticlockwise until I touch a line of what? Of a given vector. This specifically, or this actually shows that you are moving from where? From south going towards east. That's what they're trying to mean in this case. Then you put your 20 degrees where? Your 20 degrees at that given point. Okay, again, there are cases whereby they will just write it like this. If they write east, then they put the angle in between like this, then they write south. Here it becomes a different way of writing this same what? These same angles. And how are you going to write this same angle of this type? This specifically, it means that you're going to start from east, you move towards south by how many degrees? 20 degrees, which is in the middle. So definitely, if you have been asked like this one, you have to do it like this. Okay, let me draw it here. This is my east, this is my north, this is my south, and this is my what? My west. So if you have been given this type now, you have to make sure that you start from where? From from east, you move towards south, but you need to take how many degrees? You have to take 20 degrees. So you draw a line to show that you are given a vector, which is this one. I can put my vector A. This shows that I have to move from where? From east, moving clockwise until I touch a given vector. I mean that I'm pointing towards what? Towards the south pole. Since you are saying east, 20 degrees south. So you say 20 degrees is going to be at this given point. Okay, now there are certain cases whereby you are going to be given the angles already with each vector raised at a given angle. Suppose you have been given your vector like this. If they say this is your 20, maybe 20 degrees vector A, vector B, maybe they put it somewhere there, they put 30 degrees here, vector C, they write it like this, they put, so this is vector B, that is vector C, then they write, let's say they write 15 degrees, we put it as 15 degrees like this. So remember, like I said, if you are following this format whereby they're saying east 20 degrees south, meaning that you have to move from east moving towards south until you touch a given what vector. But in this case, if they say east of south, you need to start from the last pole given, which is what south. Then I'll have to move from here going towards the east pole. Now in this scenario, all these vectors, how do we write the angles based on these same what vectors? Okay, so let me just replace with a plain paper. I'm here just to do like this. Let me try to replace with a plain paper. Okay, so I'll do like this. All right, so what you're going to understand is, if you check on this one, we have different types of what, or we have different vectors raised from different angles. Now, how do we write these same vectors in reference to the original angles at which they are raised at? So I'll draw this same diagram so that I can know the angles, how they are read. Reading the angles and showing the direction, two different things. So suppose we draw all these three vectors on this compass. We have east, north, west. We also have the south pole. So vector A, we are saying vector A has been raised at an angle of what? 20 degrees. That is my vector A. Then if you go to vector C, we are saying it has been raised at an angle of what? 15 degrees. So this is vector C. Vector B has been raised at an angle of what? An angle of 30 degrees. So reading the angles for each vector, you need to move from positive x-axis going and clockwise. This point is very, very important. You have to move from positive x-axis going and clockwise until you touch a given angle. So suppose I want to start from A, for vector A. If I'm to move from positive x-axis going and clockwise, you'll find that I'm going to touch this vector just from here up to that given point, and its angle now, the original angle at which it was raised, will be what? Will be 20 degrees. So we're going to say vector A has been raised at an angle of what? At an angle of 20 degrees from positive x. All right. Whenever you go to vector C, you're going to understand that for you to reach at this given point, moving from positive x-axis like this until you touch this given vector, this is a straight line, and always we learn to grade 7 that straight line add up to 180 degrees. So you're going to understand that if you move from here going and clockwise until you touch that given vector, what angle are you going to find in this case? You're going to say 100 degrees for the straight line minus the angle which has been given already. In this case, we're talking about 15. So if you subtract this from 180, what you're going to understand is vector C now is going to be raised at an angle of what? At an angle of 165 degrees. So remember, all these angles we're finding are the ones that we're going to use to resolve each vector into its components. So you come to vector B. This is vector C. Vector B, what it will be, you're going to say, you move from here, moving anti-clockwise. You move like this. We're going to do like this. Going to move like this until I touch this given vector. So this first quadrant is 90 degrees, and also 90 degrees. Whenever you add all these 90 degrees, you're going to find that you're going to get what? 270 degrees. Then for you to find what is the angle from here up that given point, you just subtract 270 minus 30 degrees, and you're going to get the angle for vector B as what? The angle for vector B as 240 degrees. So these are the same angles we're going to use to resolve every vector into its components. Wow, that's nice. I'm happy you are following, you people. All right, so how do we resolve these same vectors into their components? Remember, we are saying the axis cut by the angle, or the axis where you're starting from to read the angles, must be cut by the angle. Must be sorry, not cut by the angle, but must carry cos. Remember, when resolving these same vectors, what it is, suppose we have this given vector. Okay, let me try to write it. Okay, write it here. This vector, which is vector A, this is my vector having a resultant r. So if the theta is here, you're going to understand that this is your x-axis and this becomes what? Your y-axis. And how are you going to read these same angles, or rather to resolve this component into, this vector into its components? So if the theta, which is the angle, is given at that given point, how are you going to resolve this the same magnitude of this resultant into its components? You are going to understand that this axis, which is cut by the angle, must carry cos. We resolve this one into its components. We only have two different components. You are going to learn in the next chapter, whereby you are going to add the other component, which is what? Z component. Now in this case, we're trying to talk about x and y component only. So how do you resolve this one with respect to the same components? This is going to carry what? Is going to carry cos, reason being it has been cut by the angle. Suppose the angles at this given point mean that this one is going to carry what? Cos. And that is the way we do resolve the same what? The so-called vectors. A good number of people, they are making mistakes when it comes to resolving the same vectors. They always think that only x-axis carries cos. So how can you resolve this one? Resolving, we mean something like you have to write it like x has to be equal to what? You say r cos theta. Then you come to what? To y. You're going to say y has to be equal to what? R sin theta. That's how we do resolve these components. So meaning that even here, depending or based on these ones, I have to resolve each vector into its components with reference to what? To these angles. So I'll resolve this one into x and y component, but the one which is cut by the angle starting from here moving like this must be carrying cos. So this one, if you resolve it into its components, you're going to find that vector A into its components is going to have what? A cos 20, and then the other one is going to be what? A sin what? Sin 20 degrees. This one is for y, that one is for what? For x. You come to vector B. You understand that vector B, if you resolve it into its components, you're going to have B cos the angle you got now as the what? As the original angle, which is going to be 165. And you say comma C, say sin 165, like this. Okay, just a bit. I want to make everything stable. All right. What about vector C? Vector C, again, you have to write it like this. For vector C, its components are going to be, you say C cos. So this column is for what? For x components of each vector. This column is for what? For y components for each what? For each vector. So this one is going to be what? 240. Then you come here, you say C sin 240. Now, how do you get the magnitude as well as the resultant for these three different vectors? How do you get their magnitude and the resultant? For you to know the resultant, what you have to take into consideration is you are going to sum up all these vectors in the part of x component. You can just pick your calculator, then where there is a is a specific vector that you are going to be given where? At this given point. While there is b, you put the vector given for b at this given point. While there is c, you put for what? For c on each column of specific components. All right, guys, we are moving in the slow pace. We are trying to do our best. Okay, so that's how we have to follow whenever you want to find, that is, if you want to find the resultant in where this one is going to have a resultant in x axis, and also this one is going to have a resultant in where? In y axis. The results you are going to get once you add these. You can just say, for instance, here we had 15 newtons. Remember the examples of vectors, you can watch the first video where we gave the examples for what? For vectors. So suppose here we have 15 newtons. Automatically I will say 15 sin 20. Then I'll add the other one which are going to be given where? On this one. Sorry, this has to be, okay, see here. This has to be B. You do likewise here, and then also you go to the other component. So the results you're going to get after punching everything on your calculator, you write it here. You can even leave it to 2 decimal places, something like that. 4 significant figures, they are all accepted. Okay, so I think now we are able to resolve the vectors into its components. Now, how do we write the same what? How do we write the answers now for direction? Remember, we are going to have Rx and also Ry. These two, you can base on this given point whereby you're going to have what? You're going to have, here we are going to have what? Rx, that is the resultant in what? In x-axis, of which if you clearly follow it, you're going to understand that this x-axis is going to have what? Rx. This y-axis is going to have what? Ry. So it's more like we're doing something like this. You're going to have something like this. Then you to have something like this. So we want to find this angle which is here, following the vector which is the resultant that I resolved in this case. You are resolving this one, you want to take it into its components. So you have Ry, Rx, like the way I've written here. Now the distance from here up to there is the what? The Ry. From here up that given point is your Rx. Now I think you still remember what you used to do to secondary level, whereby if they say calculate the angle, blah 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 blah, we are using this guy by the name of SOHCAHTOA. SOHCAHTOA. So this first part, it means sine has to be equal to the opposite over hypotenuse. This is my hypotenuse, this is my what? Opposite, and this becomes my adjacent. Cos has to be equal to what? Adjacent over hypotenuse. For tan, you have to say opposite over adjacent. So here we are going to be dealing with the adjacent as well as the what? The opposite. Now, which identity do you think you are going to apply here? For this one, that one, and this one. Wow, I feel like it has to be this one. Reason being, it has the opposite and the adjacent. Hence, how do you write the same directions? I will say, for direction, I'll say tan, the theta, you have to say this has to be equal to what? What is my opposite in this case? My opposite is what you're going to get here. What you get here for Ry has to be your opposite. So in this case, my opposite is going to be what? My opposite is going to be Ry over Rx, which is what? My adjacent. You're done with the part of finding the direction, but this doesn't mean that you have found the direction already. Direction means that you have to get the theta. For you to get theta, you have to say tan inverse of Ry over Rx. If you don't know what tan inverse is, on your calculator, just punch shift, then you punch on tan. You're going to observe that it will give you what? Tan inverse of that. Okay, we are done with this part. What about the issue of how to make sure that you get the correct answer here? Remember, we don't use the so-called tan anyhow. No, tan can only be used if you have a specific thing like this. You know the direction once you find the magnitude. By the way, I forgot to make mention on how to find the magnitude, but I'll tell you. So tan, how do you use tan? Tan has to be used in this case. You have this theta. If these two different resultants, the other one is having a negative, you need to plot it and know which quadrant you're likely to do to follow. Suppose here this one is having a negative, this one is having a positive. Automatically, if you go on this simple diagram, you understand that this one is going to have what? Rx, which is negative Rx. Why? Because we are getting a negative thing there. And then definitely the other one, which is what? For y. For y has to lie where? In the positive part. Mean that the quadrant where the resultant is going to be has to be what? The second quadrant. Reason being, we're having a negative as the first thing. It's more like we are plotting negative 5, 2. Which quadrant do you think is going to lie? You have to say this is what? For my negative 5. And then this one is going to be for my what? For my positive r in this case. Now, you want to find the direction. We don't calculate direction anyhow, no. If you're having a negative for this and this one is having positive, first of all, you need to calculate using positives for each resultant. After you do that now, the next thing that you're likely to do is what? You need to understand that the next thing that you have to do is what angle we're going to get here now, you can refer to this. Which quadrant are we following? If you fall under this quadrant, which is the second quadrant, I think you still remember this kind of thing, this kind of simple thing whereby we are saying all the identities here, they are positive, only sine in this case, only cosine, sorry, only tan in the third, fourth we have cos. So here, since we're having -1 of the thing, it means that you follow the quadrant where you're going to find tan as a negative what identity. In this case, it's this one. You follow. I mean, you have to follow the second quadrant because of this. Once you plot this and that, you're going to understand that you have what this quadrant. So since we are finding the first thing which you're going to find, it means that you are finding what I will find the first quadrant for what for that. Once you exclude this negative. And then the next thing now you have to do, you follow this what quadrant. What are you supposed to do for you to know the angle? You say 180 minus the angle you're going to get where? To get that side. Then you are done with the part now of finding the what the direction. Magnitude, how do you calculate for magnitude? For you to calculate for magnitude, the magnitude can just be calculated as in. So for you to know the magnitude of a given different types of vectors, you say R as the what resultant, which is in a form of magnitude. This has to be equal to what? You say root of r x square plus r y square. So what you are from getting here as the resultants, you have to put them what? You have to put them under the root by squaring each. But if you are having a negative resultant in the part of x or maybe y, whichever, you have to understand that you put it inside the brackets, then you raise it to power what? To power 2. Same applies to that part. Okay, so I think this is all what we have to follow whenever you want to resolve the vectors into their components. If you have a case whereby you have been given the angles already, to say, for instance, vector A at an angle of 0 degrees, automatically this means that this one, the way it is, this is my 0 degree, this is my 90 degrees, this is my 180 degrees, this one is 270 degrees, and this becomes 360 again degrees. So you are going to understand that all the angles in the x-axis, they support cosine. If you punch these angles in the x-axis, you understand that if you punch the angles on the part of positive, if you say cos 0, you're going to get what? 1. But if you punch on the negative side, you're going to get what? You get -1. But if okay, for instance, you want to punch sine in the x-axis, all the angles in x-axis supports cos, not sine. If you punch sine 0, you're going to get 0. Sine 360 is 0. Sine 180 is what is 0. Again, in the y-axis, it becomes the opposite way around. Here, all the angles in the y-axis supports what we call sine. If you punch this one, you're going to get what? If you say sine 90, you're going to get 1. If you punch this one, you're going to get what? You're going to get -1 for sine. Then if you keep moving here, if you go on this given point, you add 90 to this one, you're going to get what? 450. When you add 90 again here, you're going to get 540. Mean that all the angles in x-axis, they still support what? Even this one, if you punch this, you're going to get -1. Try it on your own. Pause the video, try it on your own. If you punch this one, you're going to get 1. If you add 90 here, what answer you're going to get? Definitely you're going to get 630. If you punch this on your calculator, you understand that you're going to get -1. Whenever you continue here, this is where now we have to do what? We have to, sorry, is it 90? Okay, yeah, 630. If you go in this one, what answer are you going to get? The answer you're going to get here must be, I think it has to be 720. Okay, so we proceed. This is how we know the angles, which component is giving us 0. So meaning that if there is an angle, maybe for instance, if they say south, suppose they say vector B was raised at an angle of, maybe it moved in the south direction, meaning that it is pointing towards 270 degrees. If it is pointing towards east part, automatically this one is what? 180 degrees. If they say towards east, towards towards east. If they say towards east, it's 0 degrees. Towards west, it has to be what? 180 degrees. Towards north, it has to be what? 90 degrees, something like that. So all the angles, we do calculate them, or we do resolve them based on each on each angle. Sorry, all the vectors, we resolve them based on each what? Each angle specified. Okay, I think we've talked much on how to resolve the angles, how to read the angles, how to resolve the vectors, how to read the angles. If you haven't understood, try to rewatch the video and you'll be able to do it to get the concept. So in a case, if you see that a vector is pointing downward like this in a straight line, automatically it has an angle of 270. No need of you reading again to say I'm moving from positive x. All the angles in these axes, they already have their specific vectors. So suppose you have this vector which is having something like this, the other vector pointing like this, maybe vector b, the other one pointing like that vector a, the other one is pointing like this one, vector c, it is pointing like this. So no need of troubling yourself here. This one is 270 degrees, this one is 90 degrees, this one is 180 degrees. But remember what we are from saying, all the angles that are all the vectors lying in the x-axis, they support cos. So if you punch or you try to resolve this vector into its components, you are going to understand that it will only support cos and not sine. Sine will be 0. Hence, don't even panic yourself. Even here, you won't have any component for what? For x component. Reason being, these two vectors, they lie in the y-axis. We've talked much. Thank you for watching the video. Subscribe to our channel as you are waiting for the other chapter, that is 3 by 3, or rather 3-dimensional vectors. Thank you.